Have you heard the phrase, data is the new oil? But who manages the oil rigs? Who ensures that the data is fast, safe, and never lost? That is the job of an MSSQL DBA. Hi, my name is Mohan, and after 17 years of managing mission critical databases and fixing production issues, I am launching a complete crash course for MSSQL DBAs designed to take you from a beginner to a job ready professional. There are thousands of SQL tutorials online, but most focus only on writing queries. This course is different. We are not just learning select statements, we are learning production management. I am going to teach you exactly what I do in my daily life: performance tuning, managing always on environments, and recovering from disasters. No fluff, just real world skills. So let's go through the curriculum. We will start with the fundamentals, understanding RDBMS, SQL Server additions, and your core role as a DBA. Then we will move to the installation and configuration, learning the best practices for memory, TempDB, and Maxstop that most people get wrong. Finally, we dive into the architecture, system databases, and how SQL Server actually manages files and memory. Next, we cover SQL basics for DBAs, the T-SQL and asset properties you need to know. Then comes the heart of the course, backup and recovery. We will master RPO and RTO, and I'll put you through disaster simulations where you will have to recover a crash production databases under pressure. Module 7 is all about security and compliance, from TD encryption to auditing. Then we get into my favorite part, that is performance tuning. We will analyze execution plans, use DMVs, and solve real world issues like deadlocks and blocking by mastering concurrency and isolation levels. Finally, we will reach the advanced levels. We will build high availability solutions using log shipping and always on availability groups. We will automate everything using SQL agent and PowerShell and finish with real world capacity planning and data movement. The best part is every single module ends with a real world interview questions and explanation. So you are not just learning, you are getting job ready. So let's start our course. So the first question is, what is database? A database is like a super organized digital cabinet on your computer, or you can say digital filing cabinet on your computer. It holds all kinds of structure information like names, numbers, or dates. So you can easily store it, find it, pull it up, update it, or manage it using a special software called a database management system, or DBMS. If we break down the parts, every database has three main building blocks. First, the actual data, which is just raw stuff like text, numbers, or customer details. Second, the schema, which is like a blueprint. It sets up tables, columns, and how everything connects, kind of like organizing folders in a cabinet. Third, the DBMS software, such as SQL Server or PostgreSQL. It does the heavy lifting. It runs searches, it keeps things secure, it backups your files and lets multiple people access it safely. So databases let you add new information, edit what's already present, create reports, or analyze trends using simple commands like SQL. Think of SQL as the universal key to unlock and tweak your data. In relational databases, it also guarantees everything stays reliable with ACID rules. Atomicity means a change either fully happens or not at all. C means consistency. Consistency keeps data valid. I is for isolation, that stops mixing up during multi-user edits. And D for durability, it saves the changes permanently even if the power fails. So what are the common types of databases? There are two common type of databases. One is relational database, other is non-relational database. So relational databases work with tables full of rows and columns, and it is perfect for the structured data. Examples of relational databases are SQL Server, MySQL, Oracle, and so on. The non-relational database or NoSQL databases, it handles messy and unstructured data like social media posts through flexible formats, key value pairs for quick lookups, document store for JSON like files, or graphs for mapping connections like friend network. So if you have ever wondered how apps like Zomato, Amazon, or even your bank keep track of millions of records and users without making mistakes, the secret is a technology called the RDBMS. RDBMS stands for Relational Database Management System. Think of it as a super organized digital filing cabinet, as I said earlier. Instead of just throwing data into a folder, it stores information in tables. These tables have rows for each records, and these tables also have columns for categories. It can be like name or phone number or address. To link these tables together, we use keys like the primary key, which ensures every piece of the data has a unique ID. Why do big companies use RDBMS? Because it's incredibly reliable. It follows something called ACID properties. Essentially, this means if you are transferring money to a friend, the system ensures that either the transaction is 100% successful or it does not happen at all. Your money won't just disappear in the middle. It also handles thousands of users at the same time and keeps your data secure. Now, you might ask, is it the same as a normal DBMS? Not exactly. A DBMS is like a simple digital diary where you store data. An RDBMS is a relational system. It follows the rules of the relational model, which was invented by E.F. Cord back in 1970s. The biggest difference in an RDBMS, you can link different tables using joins. For example, you can link a customer table to an orders table instantly. You can also define the relation between the tables using foreign keys, as I said earlier. If you are learning SQL, you are already using RDBMS. Popular examples of RDBMS are MySQL, which is very popular for the websites, Microsoft SQL Server, that is great for big businesses, or Oracle, which is used by major banks. In short, RDBMS is the backbone of the modern internet. I hope this made RDBMS clear to you. What is SQL Server? SQL Server or SQL Server is an RDBMS developed by Microsoft with its first version 1.0, and now the latest version is 2025. Its primary job is to store, manage, and query data for big businesses. It uses a core database engine that handles everything from your simple data entries to your complex security and high speed transactions. To understand SQL Server, you should know it has two main parts working behind the scenes. First one is the relational engine. Think of this as the brain. It takes your SQL queries, figures out the best way to run them, and processes the logic. Second part is the storage engine. This is the muscle. It manages the actual files, indexes, and buffers on your disk. As a DBA or as a database administrator, we spend a lot of time in SSMS, that is SQL Server Management Studio. It's a visual dashboard where we do things like performance tuning, backups, and query optimization. Now, why do banks and hospitals use SQL Server? Because it almost never goes down. It features a technology called always on availability groups, which we will cover in our course. This ensures that if one server fails, another one takes over instantly. This kind of high availability is what keeps the world's most critical apps running 24 by 7. So now as we have understood what is SQL Server, now let's look into the addition and versions of SQL Server. SQL Server offered different edition and versions. It started in 1989 with version 1.0 and today the latest version of SQL Server is 2025. It is also available in the cloud as Azure SQL for managed services and we can also use it in the hybrid mode. So in the on-premises, we have mostly three or four editions of SQL Server. First is the Enterprise Edition. So this is just like a supercar. It has no limits. It supports unlimited memory, advanced AI features, and up to 8 always-on replicas. This is where we spend most of our time during the performance tuning for big clients. The next one is the Standard Edition, the middle class of SQL Server, you can say, and it's perfect for mid-sized companies. It gives you basic always-on features and good performance. And we have Express and Developer editions as well. So those are the free ones. Express is a great for small apps but has 10 GB limit. Developer edition is the full enterprise version but only for learning and testing. But what if you don't want to manage a server? That's where Azure SQL comes in. It's a platform as a service or PaaS, which means Microsoft handles and updates the security patches for you. Azure SQL databases is the best for modern web apps. It can even be serverless, meaning it only charges you when it's actually being used. Azure SQL Managed Instance. This is for the companies moving from old servers to the cloud. It's almost 100% compatible with your old code but runs on Azure. Now, here is a pro tip for my fellow DBAs and business owners. The Azure hybrid benefit is if you already own a license for your Office server, Microsoft lets you use that same license in the cloud. This can save you 40 to 85% of the cost. You can even link your local server to Azure for a hybrid setup. If your Office server fails, Azure can take over instantly using the always on failover as we discussed earlier. So, if you are a student, start with the developer edition. If you are a business, look into the Azure SQL to save on the hardware cost. So the database engine is the heart of SQL Server. It's the core service that stores and secures your data. Now to talk to this engine, we usually use SSMS or SQL Server Management Studio. Inside the engine, the first stop for your query is the relational engine or the query processor. It has three main jobs. First is CMD parser. It checks your T-SQL for mistakes. It asks, is the syntax right? Does this table even exist? Then we have a query optimizer. This is the most important part of the performance. It looks at different ways to run your queries and picks the one with the lowest cost or the fastest time. Then comes the query executor. Once the plan is ready, this part tells the system to go get the data. Next is the storage engine. This is where the physical work happens. It ensures our data is safe and follow asset rules through four key managers. First is the buffer manager. So it caches the data in memory so we don't have to keep hitting the slow hard drive. Next is access methods. It decides how to find the data using indexes. It is essential for the tuning work we do. Next is log manager. It records every transaction in the transaction log so we never lose the data. The last one is the log manager. This handles concurrency. It makes sure two users don't try to change the exact same piece of data at the exact same millisecond or at the same time. As a DBA, why do you need to know all of this? Because when a query is slow, you need to know if the bottleneck is in the optimizer, maybe due to the bad execution plan, or the storage engine, maybe due to the slow disk or locking issues. Mastering these two engines is what allows us to build rock solid, always on environments that never fail. If the SQL Server database engine is the engine of a car, then SSMS or SQL Server Management Studio is the dashboard, the steering wheel, and the GPS all rolled into one. As a DBA, you will spend 90% of your time here. First up is SQL Server Management Studio, or as I said, SSMS. It's a free tool from Microsoft that acts as your main command center. For developers, it is where you write and test T-SQL queries. And for DBAs, it's where we manage security, we run backups, and we look at the execution plan to see why a query is slow. If you are working with Always On in SSMS, you can also see the dashboard to check if your secondary replicas are healthy and if they are in sync. Next is the SQL Server agent. Think of this as your personal assistant that never sleeps. It handles jobs. If you want your backups to run every night at 2 a.m., or if you want an email alert if a server goes down, you set that up here. It's the backbone of database automation. Now, what if the server is acting weird and you need to see what's happening right now? Here comes the SQL Profiler. The classical tool, it's a great for quick look, but it can be heavy on server resources. Next comes the extended events. In 2025, this is the standard. It uses very little fuel and gives you deep data on deadlocks and slow performance. SQL Server isn't just about storing data, it's about moving and analyzing it. That's where SQL Server Data Tools comes in, or SSDT. So for ETL, moving data from Excel or other databases into SQL, we use SSIS. So SSRS is used for creating professional charts and reports for managers. SSAS, or SQL Server Analysis Service, is used for big data cubes and advanced data mining. Finally, the SQL Server Configuration Manager. This is a behind the scenes tool. You use this to start or stop services, change the accounts the server runs on, or enable network protocols so your apps can actually connect to the database. So, what is the responsibility of a DBA? A DBA is the heart surgeon of a company's data. If the database stops, the business stops. A DBA has four main goals: availability, performance, security, and recovery. Whether it's a small startup or a massive enterprise, our job is to make sure that the data is always reachable. It is lightning fast, it should be safe from hackers, and can be recovered in seconds if something goes wrong. So, what does DBA's typical morning look like? So, we do health checks. DBA usually starts by checking error logs and running DBCC check DB to ensure there is no data corruption. But be very careful, this check DB you should not run very often in production without an issue. Second is the maintenance. Then DBAs look at the index fragmentation and update statistics. If the stats are old, the SQL optimizer makes bad choices and your queries get slow. The next one is the backup verification. A backup is useless unless it is recoverable. DBAs verify these daily to ensure we are always on ready. One of the main aspects of being a DBA is a performance tuning. This is where the real fun starts: optimization. DBA spends a lot of time in the SSMS analyzing execution plans. DBAs look for missing indexes, expensive table scans, or bad T-SQL code. The goal of a DBA is to reduce CPU and memory usage so the application feels smooth for the end user. Next is the security and high availability. DBA provides security seal. DBA manages logins, roles, and use transparent data encryption or TDE to keep the data safe. But the biggest part of my specialization is always on availability group. This involves setting up failovers. If one server catches fire, the second one takes over automatically without the user even noticing. Then automation and planning. We don't do everything manually. We use SQL agent to automate alerts and SSIS to move data. We also do capacity planning, predicting how much storage we will need next year so we don't run out of the space unexpectedly. Now consider it's 3 a.m. Your phone is screaming on the bedside table. You pick it up and see a critical alert. Production database down. This is the reality of being an on-call DBA. In my 16 years, I have handled hundreds of these calls. Most companies run 24/7. If a bank's database stops at midnight, people can't withdraw money. As an on call DBA, you are the first responder. You are responsible for production stability outside of regular office hours. Usually, you work in a rotation, maybe once a week, every month. You are the person everyone calls when the timings break. Now, as I promised, I will be covering the interview questions as well regarding this topic. So, you may have the question, or the interviewer may ask the question, what is the difference between our DBMS and RDBMS? So, the answer is a DBMS or database management system is any software that stores data. An RDBMS or relational database management system specifically stores data in tables and enforces relationship between them using the keys, maybe primary or foreign keys. RDBMS also strictly follow ACID properties. The next question may come, or the follow-up question will be, what are the ACID properties in SQL Server? So A stands for atomicity, C stands for consistency, and I stands for isolation, and D stands for durability. Atomicity is all or nothing. Consistency means it should have the valid data state. Isolation means concurrent transactions don't crash. And durability means data is saved even after a crash. The next question is, what is T-SQL and how is it different from standard SQL? So SQL or structured query language is the universal language for databases. However, T-SQL or Transact SQL is Microsoft proprietary extension of SQL used specifically for SQL Server, adding features like variables, error handling, and row processing. Next question is, explain the role of primary keys and foreign keys. I have already discussed this in my video, or you can follow the playlist of SQL Server development course. There I have explained it in detail. But for now, to answer this question, a primary key uniquely identifies a row in its own table. A foreign key is a column that creates a link to the primary key of another table, ensuring referential integrity. Next is, what is the difference between SQL Server Developer and Express Edition? So answer is both are free. Developer Edition has all the features of Enterprise but is for the dev and test only. Express is for small production apps but has only 10 GB database size limit and limited CPU and RAM usage. Next question is, when would you choose Azure SQL Managed Instance over Azure SQL Database? You can choose Managed Instance if you are near 100% compatible with on-prem features like SQL Agent or cross database queries. you can choose Azure SQL database for modern cloud native apps that only need a single database. What is the Azure hybrid benefit? As I said, it's a licensing program that lets you use your existing on premises SQL Server licenses to get a massive discount, maybe up to 85% on Azure SQL services. Next question can come like, can you explain what hybrid SQL means in a production environment? So it's a setup where some data stays on premise while some is in the cloud, often linked by always on availability groups for disaster recovery or Azure Arc for centralized management. Next is, what are the two main engines within the SQL Server database engine? So we have relational engine or query processor, which parses and optimizes queries, and the storage engine, which handles the physical reading or writing of the data and the buffer management. What is the query optimizer and how does it work? So query optimizer is a cost-based optimizer that analyzes multiple execution plans for a query and selects the one with the lowest estimated resource cost, that is CPU or IO. What is the purpose of SQL Server Agent? It is a Windows service used to automate tasks. It runs jobs like backups, index management, index maintenance, and sends alerts if a server fails. Name three tools other than SMS used to manage SQL Server. The answer is Azure Data Studio for cross-platform, SQL Server Configuration Manager for service or network setup, and SQL Server Profiler or extended events for the troubleshooting. So this is it for today. I hope you have learned something new today, and I'll see you in the next video.